Hey there, Mr. Weaver here. This is Module 5, Lesson 2, Writing Equations in Standard and Point Slope Forms. However, in this section, we are only going to focus on parallel and perpendicular lines. After this lesson, you need to be able to create and identify equations of parallel and perpendicular lines. Let's learn. Equations of parallel and perpendicular lines. Non-vertical lines in the same plane that have the same slope are called parallel lines. Non-vertical lines in the same plane, for which the product of the slopes is -1, are called perpendicular lines. And as we go through with perpendicular lines, we're also going to say that they intersect at a right angle, or a 90-degree angle. So our key concept here, the slopes of parallel and perpendicular lines. One of the big aspects of parallel and perpendicular lines is their slopes. In our definition, same slope was parallel, product of the slopes being -1 was perpendicular. It all has to do with their slope. So for parallel lines, if the lines are parallel, the slopes are the same. So here we have two parallel lines because each line has a slope of 1/2. If I look, this line went up 1 over 2. This line also went up 1 over 2. The slopes were both the same. They are parallel. For perpendicular, their slopes are going to have a product of -1, which, when we're looking at it, they are going to be opposite reciprocals. So their fractions are going to be flipped, and then one's going to be positive and one's going to be negative. So if we look here at E to F, I'm going to just choose 2 points on the line. E to F went down 2 and over 1, so it had that slope 2 over 1 going down is negative, so -2. 2 over 1, and it was going down, negative. Whereas A to B is going up 1 and over 2. So notice these two fractions are flipped. One's negative, one's positive. When you see this, those are perpendicular lines. And using their definition, they multiplied them together. 1/2 times -2 is -1. And if the product of the slopes is -1, they're going to be perpendicular. Let's learn equations of parallel and perpendicular lines. You can write an equation of a line that's parallel or perpendicular to a given line if you know a point on the line and the equation of a given line. So our key concept here is writing the equations for parallel or perpendicular lines given a line. For parallel lines, first you're going to identify the slope of the given line. So remember, if it's in y equals mx plus b, slope-intercept form, your slope is that number that's in front of x, the m value. Identify that first. Then, step 2, we're going to use slope-intercept form again with that slope that we just had and a point that's on the line. You can also use what's called point-slope form, but I'm not going to go through that here. We're going to take the slope and the coordinate, plug them into slope-intercept form, and solve for the y-intercept. Then, last, after we figured out the y-intercept, we're going to take our slope, because if they're parallel, they have the same slope, and our newly found y-intercept, and put them back into our equation. So we have an equation of a parallel line. We'll look at this in the next example. For perpendicular lines, the process is similar. However, once you identify the slope, you are going to do the opposite reciprocal of that slope, and that's what you're going to use. So whatever your slope was originally, you now need to make it the opposite sign. Then you need to flip it, and you're going to use that slope. They write it as -1 over m, just showing that the slope was flipped, and now it's the opposite sign. We're going to plug it in just like with parallel, along with the point that we're given, solve for the y-intercept, and rewrite our equation. So the steps are very similar, just what you do with the slope is where it's different. Example 7, a parallel line through a given point. Write an equation in slope-intercept form for the line that passes through -4, 2, and is parallel to the graph of y equals 3x minus 5. So first we need to identify the slope of the given line. So here's our given line. The slope in that equation is 3. It's the number in front of x. So if this line is going to be parallel, it needs to have the same slope. So also is going to be 3. Then in steps 2 and 3, we're going to write our new equation for our parallel line. So I know that the slope has to be 3. I'm going to plug that in for m in our y equals mx plus b. We also know that we have to go through the point -4, 2. So I'm going to use those values as my x and my y. X is -4, y is 2. So we're going to plug those in. Now let's multiply it out and solve for b. So 3 times -4 is -12. So I would need to add 12 to both sides to get rid of it off of that right side and get b by itself, giving me 14 on the left. So b is equal to 14. And then last, I'm going to take the values that I just figured out for b, which is our y-intercept, and our slope we already know was 3. I'm going to plug those back into slope-intercept form. So we already plugged in 3 in front of x. If I plug in plus 14 at the end, that is my new equation, y equals 3x plus 14. So that equation is the line parallel to the one that I was given through the point that it said. We can also use Desmos to help us figure this out as a more visual option. So I typed in the equation that we're given, y equals 3x minus 5, and the point we needed to go through, -4, 2. I know my slope has to be 3. So I know my new equation for a parallel line is going to have that same slope. Then if we think about what we need to do to get it to go through that point, we would have to move our y-intercept up. How much do we have to move it up? Well, this is where Desmos can help us. We can kind of just guess and check. So 10 didn't move it up quite enough. 12, not quite enough. 13, 14. So I knew when it was going through 0, 0, it wasn't high enough because the point was above it. I had to move my y-intercept up to 14 in order for it to go through the point that I wanted down here. So if you remember back to transformations, translating it will make it go up, and translating is just moving the intercepts. If you don't want to guess at how far you have to do it, when you type in your new equation with your same slope, you can just count the spaces. So if we think about the point down here, which is on the same line as this point we want to go through, how many spaces would it have to go up? Here's 2, 4, 6, 8, 10, 12, 14. It would have to go up 14 spaces in order to go through that dot, so plus 14. Check your understanding. Write an equation of the line that passes through 8, 2 and is parallel to the graph of y equals 3/4 x plus 2. Pause the video now, complete the check. Check your answer. You should have said that the parallel line's equation is y equals 3/4 x minus 4. So it has the same slope, but a different y-intercept. Example 8, perpendicular line through a given point. So this time, let's write an equation in slope-intercept form for the line that passes through 1, -2, and is perpendicular to the graph of 3x plus 2y equals 12. First, we need to identify the slope. So we have to write that equation in slope-intercept form. So to do that, we would subtract our x from both sides to start getting y by itself, because slope-intercept form is that y equals mx plus b. Then let's just switch it around. So we have 2y equals -3x plus 12, because in slope-intercept form, or y equals mx plus b, that mx comes before the b number at the end. Then to get the y equals part, where it's just y, then we have to divide both sides by 2. We would end up with -3/2x plus 6. That is our slope-intercept form. Now that we know that the slope of that line is -3/2, the slope for the perpendicular line is going to be the opposite reciprocal. So we have to flip the fraction. So now it's 2/3. And because it was negative, now we're going to make it positive. So using that positive 2/3 as our perpendicular slope, now our steps are the same as they were for the parallel example. So we're going to plug it in. 2/3 is our perpendicular slope. Our point was 1, -2. So now let's solve for b. Multiply out 2/3 times 1. Right now, I'm just going to change -2 into -6/3. thirds because 6 divided by 3 is 2. That way, when I subtract 2/3 from each side, I can do it. So negative 6/3, subtracting 2/3 from each side would give us negative 8/3. So negative 8/3 is B. To get our final slope-intercept form, I'm going to take my perpendicular slope of 2/3 and my y-intercept that I just found, negative 8/3. So my perpendicular line is going to be y equals 2/3 x minus 8/3. We can use Desmos to check to see if we have the correct line or to go through and help us solving it. So here I'm just going to check to see if I have the correct line. So we said our perpendicular line was 2/3 x and then minus 8/3. Does it go through the point? Yes. Is it perpendicular to the line that we were given? Yes. If you're checking on Desmos and you want to know if it's perpendicular, here's a quick hint for you. If you were to stick a piece of paper and say like the corner of your piece of paper, if it fits perfectly in that corner, it is perpendicular. If it does not fit perfectly, it's not perpendicular. So, for example, let me change this to just 2x. Notice my piece of paper, if I tried to fit it in the corner, wouldn't fit. That is not perpendicular. I also could have used Desmos initially to help find the slope. So we have our y-intercept there, our x-intercept there. My slope is going 6 and 4. So 6 divided by 4 originally is 3/2. And my line is going down, so negative 3/2. You can use Desmos again to help find your original slope, which you need for both parallel and perpendicular. Check your understanding. Which equation shown is the slope-intercept form for the line that passes through 5, 0 and is perpendicular to the graph of x minus 6y equals 1? Pause the video now and complete the check. Let's check our answer. So first, we want this into slope-intercept form. So I'm going to subtract x from both sides, then divide both sides by negative 6. So this is going to look a little complicated for a second, but that's okay. 6, negative 6. I end up with y equals 1/6 x plus negative 1/6 or minus 1/6. I want it to be perpendicular, so I know that my slope has to be the opposite of that, so 6/1, and it has to be the opposite sign, so negative 6. So whatever my equation is, it has to be negative 6x and then plus something else. So if I'm going through and looking, it does tell me slope-intercept form, which means it can't be B and it can't be D. Those are not in slope-intercept form. So either A or C. Which one's going to have the perpendicular slope of negative 6? That would be A. And again, we can double check what we get on Desmos. So I think that A was the correct answer. 6x plus 30. Is it perpendicular and did it go through the point? Well, it definitely went through the point. Is it perpendicular? Yes, I could fit a corner of a piece of paper in that graph. It's a 90-degree angle. So A is definitely my correct answer. Example 9. Determine line relationships. Determine whether line AB and line EF are parallel, perpendicular, or neither for when A is 6, 8, B is 2, 5, E is negative 6, negative 3, and F is 0, 5. So for this, parallel and perpendicular, again, all depend on the slope. So if it's parallel, they're going to have the same slope. If they're perpendicular, they're going to have opposite reciprocals. Or if you multiply them together, you get negative 1. So let's find the slope of each line. We're going to use the slope formula where we're subtracting the coordinates. So for AB, y minus y, 8 minus 5, is 3. And then x minus x, or 6 minus 2, is 4. So the slope is 3/4. For EF, if I do negative 3 minus 5, I get negative 8. If I do negative 6 minus 0, I get negative 6. If I reduce that, I end up with positive 4/3, since two negatives make a positive. So now let's see how they compare. Are they parallel? Well, these two lines do not have the same slope, so they are not parallel? Are they perpendicular? If we were to multiply these together, we get +1. Since the product is not -1, these are not perpendicular. So this would be neither. It's not parallel, it is not perpendicular. In Desmos, I can also check to see if they're parallel or perpendicular, just knowing what those two look like. So here, instead of typing each coordinate in a new line, I put A and B together in the same line, because if I do that, then I can always turn on the line, even though it doesn't cross the other one here, it still might kind of help us to look. I can do the same for E and F. I can turn on what the lines look like. So, knowing what they look like, if I were to kind of extend them as best as I can, so they cross, are those going to be parallel? They cross, so they're not parallel. Are they perpendicular? They are definitely not perpendicular. I could not fit a piece of paper perfectly in the corner. It would have to be somewhere along the lines of that, so I could fit my piece of paper in the corner, and it doesn't work. So this is neither, and I can see that just by looking at it. They don't make a right angle, but they do cross. So this is neither. Check your understanding. Determine whether line CD and line KL are parallel, perpendicular, or neither for the points given. Then, complete each sentence given y equals ax minus 5 and y equals bx plus 3 for those specific values, again determining if they are parallel, perpendicular, or neither. You may use Desmos if you wish. Pause the video now and complete the check. Check your answers. First, CD and KL are parallel. They both have a slope of -2/5. For our equations with A and B, the first one's parallel. If A and B, which are both the slopes, if they have the same slope, they're parallel. If A is -3 and B is 5, they're not the same, so they're not parallel. They're not exact opposites, where one is flip of the other, so that would be neither. And the last one, -2 and 1/2, those would be perpendicular because this is really 2/1. So they are flipped and opposite signs. They are opposite reciprocals. Or if you multiplied them together, you do get -1.